I'm Gayatri, working as assistant professor in EC department at SMS College of Technology. Today I'm going to discuss about the topic decoder, which is under the unit to combination circuits studied by digital electronics for the second year students. Today I'm going to discuss about the introduction part of decoder and how the decoder are represented with the help of diagrams, and the classification and what are the types of decoders, and the decoder with enable pin will be discussed, and in between the presentation there will be activity and assessment questions related to the topic what I have presented. First, coming to the decoder part, the decoder is nothing but it is one of the logic circuit which comes under the combinational logic circuits. The combinational logic circuits is nothing but it will be produce the output with the help of input, and none other feedback circuit is required to produce the output. That the decoder which converts the binary information from coded format, that is from n input is given to the decoder part, and it will be producing the 2 power unique outputs, where in the decoder the input codes and output codes will be totally different. The coming to the decoder type, the first one will be 2 cross 4 decoder. The 2 cross 4 decoder represents the 2 which represents the input and 4 which represents the output, where which is having 2 input A0 and A1, and which is having 4 output D0, D1, D2 and D3. This boolean expression which will be related with the help of truth table. First we are going to discuss about the decoder without the enable pin. First, the input A1 and A0 0 0 0 1 1 0 and 1 1, which is having output when the input is 0 0, the output will be the D0 will be on. When the output is 0 1, the output will, D1 will be glow. When the input is 1 0, the output will be D2. Then 1 1, the D3 will be 1. Then the boolean expression for D naught can be written as D naught which is equal to A1 bar and A0 bar, and D1 which is equal to 0 represents bar and 1 represents without bar, A1 bar and A0, and D2 represents A1 and A0 bar, and D3 represents 1 1, so A1 and A0 bar. Then coming to the Boolean logic diagram related to the Boolean expression, for input A0 and A1 with help of NOT gate it can be related, and for D0 the Boolean expression is A1 bar and A0 bar, so it is represented in NOT gate and it is connected using AND gate. And D1 A1 bar and A0, A1 is represented in NOT gate, and A0 it is simply taken from input side, and it is followed by AND gate. For a D2 and D3 same, the NOT gate is used, after that the AND gate is used. From this logic diagram we can know there is only 2 input and 4 output is there. Then coming to the activity which is related to the digital circuit design, what we have studied. Then coming to decoder with enable pin, for same type 2 cross 4 decoder, only in addition to that we are having only enable pin. En represents enable pin which is active always. When input A and B 0 0 0 1 1 0 and 1 1, the enable pin will be 1, that is enabled, that is actively high. When A and B is in don't care condition, the enable pin will be disabled. In this case the output will be same as that of 2 cross 4 decoder. 0 0 enable pin also 1, the output Z0 will be 1 and Z1 will be 1 and Z2 and Z3. When the enable pin is 0 and the A and B is don't care, all the in output will be 0. Then coming to the decoder type, which is 3 cross 8 decoder, where it is having 3 inputs and it is having 8 outputs. A, B, C is a 3 input and 8 output, Y0 to Y7. When there is 0 0 0, the y0 will be 1 and 001 y1 and 010 y2 and 011 y3, 100 y4 and 101 y5 and 110 y6. Then 111, the simply the y7 will be 1. Then coming to the assessment questions, first we what is encoder, and second question, devices which converts the input signal into a representation of 1 or 0 is termed as encoder. The decoder which converts a n inputs into 2 power n inputs, n output. Draw the block diagram of 2 cross 4 decoder. Okay, thank you.